Hi, good morning everyone. Today I would like to share with you the LTI response. Okay, the signal in figure 1 below with the period of T0 equal to 10 power of minus 5 second is passed through a low-pass filter. Okay, with the frequency response in figure 2. So this is figure 2. The frequency response is the amplitude and the phase. Okay, it's from minus 600 to 600, and the phase is pi over 2 and negative pi over 2. Okay, so you need to determine the output of the filter. Okay, so from the previous example, you have the exponential Fourier series expansion like this. Okay, that is xt equal to 2 over pi exponent j pi t plus exponent negative j pi t minus 2 over 3 pi exponent j 3 pi t plus exponent negative j 3 pi t plus 2 5 pi and then exponent j 5 pi t plus exponent negative j 5 pi t. So this is the expression for the exponential Fourier series. Okay, so from here we notice that the omega naught is, what is the omega naught? Do you know what is the omega naught? Okay, here we know that the omega naught is 2 pi over T naught, right? So based on the figure 1, I mean the signals, the T naught is 2. The T naught is 2. Okay, let's go back to the signal. Okay, this is a signal. So from when the signal repeat again, 0, okay, the signal start and come back again at 2. Means that the signal start again at 2. So the T naught is 2. So you substitute the value of 2. So 2 pi over 2 equal to pi. Okay. So in the question also given T naught value is 10 power of minus 5 second. So what is F naught? We need to do it in the frequency domain. So F naught is 1 over T naught. T naught is 1 over 10 power of minus 5 second, which is equivalent to 100 K. Okay, so what is the useful of the exponential Fourier series? Now I rewrite again. Alright, this is the exponential form that I copy from the slide. So from the previous example. So this is the exponential form. Okay, if you look at here, what is mean here? Just now, 1 omega naught is referred to pi. Okay, if you look at here, omega naught is pi. So, okay, so you substitute the value of pi. So 1 pi, 3 pi, 5 pi. So means what? So 1 omega naught, 3 omega naught, and 5 omega naught, right? So if in this case, what is the useful? The useful of this 1, 3, and 5, you have to take the value from the amplitude. Okay, you have the amplitude just now, right? Okay, the amplitude just now is this one. Just now you saw the amplitude just now. This is 600. This is minus 600. And the K, the frequency is referred to kilohertz. So now is 1 F naught is 100K. And then the available signal is 1 omega, 3 omega, and 5 omega, right? So you take it, the signal, you tap the signal. So 1, 3, and 5. Okay, so 1, 3, and 5. You tap the signal here. 1, 3, 5. Okay. So it depends on the expression of the exponential. Okay, so you need to find the HF. As a previous lecture, I told you that you need to. Okay, do you still remember the slide? This one. Okay, this slide is referred to the HF and the HT exponent. Okay. And what is the relationship? Okay, so HF is equal to the H1 right? So it's 100k. So I refer to 10 power of 5 is 100k. So what is the amplitude? The amplitude here, okay, what is the amplitude here? The amplitude maximum is 6. This one also 6. So should be, for 100 you get 1. Okay, so amplitude is 1. For here is 1. And the phase, if you look at the phase here for the right hand side, so this should be the positive. Okay, so for the right hand side is referred to this one. So it's the phase is the pi over 2. Okay, so it's exponent j pi over 2. Okay, then what about the hash f? Okay, wait. What about for the hash negative 10 power of 5? So for the negative side, I do have the 1. Okay, as the amplitude is 1, and the phase is negative pi over 2. Okay, now let's look at the 3. We need 3 also, right? So hash 3 times 10 power of 5, that is equivalent to 3. So amplitude is 3, and the phase is exponent j pi over 2. And then for the negative 3, okay, so negative 3, what is the amplitude? You also get 3. So 3, but the phase is negative. Okay, the phase is the negative. And then for the 5 times 10 power of 5, you get 5, and then phase is the positive. For the hash negative 5, you have again 5, but with the negative pi over 2. Okay, so why not hash positive 7? This is because the maximum of the amplitude given is up to 600. It's up to 600 only. So 700 you will get 0. So what is the point? You get just give 0. If you want to write, also can. Just that it's a hash 7 times 10 power of 5, you will get 0. Okay? So now, so you have the hash f, you have the xt. So your yt is equivalent to, so you combine these two. Okay, you combine these two. I write in the green color. So you have 2 over pi, and then you have this one, exponent j pi over 2 with the exponent j by t. Okay, so I write here 2 over pi exponent j pi over 2 and then exponent j by t plus with what? This one, plus with negative side, right? And then you have this negative. Okay, so you have exponent negative j pi over 2 exponent j by t. And then minus, okay, minus 2 over 3 pi, and then we have exponent j 3 pi t, and then you look at this one, you have 3 exponent j pi over 2. Okay, so I have minus 2 over 3 pi. Maybe I write in second row. Okay, I have minus 2 over 3 pi, 3 exponent j pi over 2, and then exponent j 3 pi t. Okay, plus with what? Plus with this one, multiply with this one. Okay, so I have 3 exponent minus j pi over 2 exponent minus j 3 pi t. Okay, plus with 2 over 5 pi and then 5 exponent j pi over 2 and then exponent j 5 pi t, and then plus the last one 5 exponent minus j pi over 2 exponent minus j 5 pi t. Okay, so you total up. Okay, you total up, you will get exponent j pi over 2 pi over 2 plus with pi. And then plus with exponent minus j pi over 2 plus pi t. Then minus with 2 over pi okay. This one cancel out, you get 2 over pi, right? Okay, 2 over pi exponent j pi over 2 plus 3 pi t, okay, plus with exponent j minus j pi over 2 plus 3 pi t. Okay, then plus with 2 over pi, cancel out this one, you get 2 over pi exponent j pi over 2 plus 5 pi t plus exponent minus j pi over 2 plus 5 pi t. So this is the output of the YT for the LTI system. Do you understand now? Okay, if you're not clear, I can just show you another example for the other part is the same. The figure of the amplitude and the phase also the same, just that from the expression of the exponential Fourier series, you get the cos omega naught t plus half of the cos 4 omega naught t. Okay, this is a phase plus pi over 3 plus cos 8 omega naught t. So just the difference is just this one. So you from here you know that what is the omega naught. Omega naught is, this is a 1 omega naught. This is 4 omega naught. This is 8 omega naught. Alright. Okay, so you have, based on the expression, you should have the value of 1, 4, 8. Okay, so you take the value from here, 1, 4, 8. Okay, 1 is refer to what? 1 is refer to 1. Okay, so you have 1, and then the phase is pi over 2, so that's why you have the exponent j pi over 2. And then for negative 1 also the same, so negative omega naught. Negative 1 is refer to the negative omega naught. So you have the 1 also, the amplitude, and the phase is negative j pi over 2. Negative pi over 2. So this is for the omega naught. Then second, you have the 4 omega naught. So 4 omega naught, you can guess that that is about the 4. So you have the amplitude is 4 and the phase is pi over 2. For negative part, you have positive 4 again, but the phase is negative pi over 2. Okay? And then the last part is the 8 omega naught. If you refer to this phase amplitude, there's no 8 omega naught because it's up to 6 only. Okay? 6 only. Because up to 6, so if you want the 8 omega naught, that should result in 0. So you will get 0 value. So for the output part, the yt is equal to, you just copy down, yt equal to the half of the exponent j omega naught, then multiply with j exponent j pi over 2, okay, and then plus with this one and this part, okay, and then plus with half of the this one. For the 4, you have this hf is 4 exponent j pi over 2, okay, and then you multiply with this one, j exponent j for omega naught, this one. Okay, so are you understand now? Hopefully you can understand by giving you this example. Okay, I share with you again another example, which is example 3. Okay, this is the HF and the phase, and from the previous question you have this one, this explanation. So what is the F naught? You need to know what is the F naught. So F naught given the 2 pi F naught is equal to pi 100k, because from the question you can't see what is the omega naught. So you know that the 2 pi F naught is pi omega naught, right? So F naught is equal to pi 100k over 2 pi. So when you simplify, you will just get 50k. So this 50k is F naught. Okay, you need to know what is F naught so that you can tap the signal here. You need to know 1 F naught is equal to what? 1 F naught is omega naught, right? Okay, F naught is 50k. So this one is what? It starts from -3 to 3. -3 to 3. Okay, -3 to 3. The summation from -3 to 3, and you have this one. And n is not equal to 0. So you have n equal to 0 is 5, because it's a square wave. N equal to 0 is 5. And then you have n equal to 1, right? 1, 2, and 3. 1, 2, and 3. Okay, so HF is 5 for 1 F naught, 2 F naught, and 3 F naught is referred to the amplitude. So amplitude here is 5, and the phase is pi over 2. Okay, that's why you get 5 and exponent j pi over 2. And then 2 F naught also the same. And 3 F naught is 0, because it's 150. 1 F naught is 50k. So 2 F naught is 100, 3 F naught is 150. So in this amplitude given, there's no more than 150. That's why you get 0. So you get 0. And okay, once you get the HF, you can get the output Y or V out. So you just substitute, you just multiply. Okay, so the V out is, for the 0 F naught, you get V in. Your V in value is 10. Okay, your V in value is 10, and the H naught value is 5, so you get 50. And then for the 1 F naught, okay, so your V in value is this one. You take it from here, 1 over j over n pi. Okay, j over n pi, then your n is 1, so j over pi only. And you multiply with the 5 exponent pi over 2. Okay, so and same for others. Okay, I hope you can understand for this, and thank you for watching.